Hello everyone, my name is Dominique. I am a graduate student with the UC Davis Institute of Transportation Studies. My solution to the Ford Code for Taxicabs mobility challenge is called SMS Taxi. The concept is that a user can send a text message and the Python Flask web app matches requests with vehicles using an insertion heuristic where the algorithm determines whether there are any taxis within an acceptable driving time from the pickup location with adequate seating capacity. So the ride request is added to the taxi where the operational cost of taking on these additional passengers is lowest. Users with similar origins and destinations are more likely to be paired, and taxis with a more fuel-efficient driving record as indicated by OpenXC data are more likely to get rides because they have a lower operating cost per kilometer. To address the mini challenge of improving safety for female riders, when a user specifies preference for an all-female taxi, the algorithm includes a cost penalty for cabs with male passengers. However, if no female-only taxis are available, the algorithm still matches the requester with a ride because it is less safe to have no access to transportation. I am recording data in a Zipcar Ford Fiesta, and as we enter the front near the OBD port, you can see the OpenXC reference vehicle interface is plugged in and the Bluetooth stream is connecting. On my phone, you can see the OpenXC connection has been successfully made. When you open the Enabler app, you can see the data is streaming, and when you go to the status, you can see the messages are being received. In settings here, you can, under recording, you can modify two options. So one, you can elect to record the trace to a local file on your cell phone. The other option is you can select to upload trace. And so I'm not showing the full target URL. However, this URL is what I use to upload the OpenXC data to AT&T Flow. This next part of the project takes in OpenXC vehicle data and uses that to inform the backend for the web app so that the web app knows where the vehicles are and can match users with vehicles. And we can see here, this is AT&T Flow. You have your post node, your HTTP in node. You have the various nodes I created where I filter out the raw input OpenXC messages for specific data points. So in this case, I wanted to retrieve longitude and latitude coordinates. In this case, I wanted to retrieve accelerator pedal position, vehicle speed, and fuel level. And finally, here I wanted to calculate fuel economy during the trip. And so all this data is sent to AT&T's M2X time series data storage through an M2X put node. And then we can see on M2X, this is actually the latest trip I took. These are locations from OpenXC. You can see in the streams, there are several streams. One is vehicle speed, another example, the fuel economy data, last 100 values of that. And so that's M2X. The final component to this web app is a fleet management console. We have the dashboard button, and this goes to a big data analysis. This analysis was done in Databricks using Spark. There are a number of metrics that you can see here. The most important for the web app backend in calculating operating cost is the fuel economy by vehicle component. So now let's text a cab. On the first line, I have West Village, Davis, California, actually where I'm at right now, and then a restaurant I would like to go to, In-N-Out, in Davis, California, the number of passengers in this group, just myself, and then my gender. I send this ride request. It processes on the back end. The result gives the vehicle name, time to arrival, and an estimate of the trip cost. Thank you for your time, and please vote for this project if you liked it.